CAP 6671 grader. This is my submission for the Robotics Path Planning and Reinforcement Learning project. Here I have two different environments, the Deterministic and Stochastic worlds. In the Deterministic world, I have my cyan blue actor down here in the bottom left in column 0, row 9, and then additionally this n square and column 9, row 0. I have two different options, one for stepping and running through the pathing, and then one for stepping and running through the movement. In the deterministic, we can't move until we have the path, so I'm going to go ahead and step through the A-star path planning module. What you're going to see in this first step is that there's a new green and new pink square. The green squares are depicting the open list nodes, so nodes that are on the open list, and then the pink is going to be the current path that I am considering. So right now I'm considering this path of the blue actor moving to the right one square. And then I also have on my open list something to look at in the future, this square on top. So if I step through again, I am now looking at this square up here. So that's the current path that I'm looking at, and I've added this green square to the open list. That's one more that I need to look at. So as I step through, we're going to see the path expand, and when you only see the pink one move, that means that there was only one green, one open list node added. So that's definitely going to be the one that I move to next. But you'll see it swap between swap through the green nodes, and it's always going to use, or it's always going to consider the open list node with the lowest F score, which is the sum of the Gaussian and the heuristic values of each node. So the Gaussian is the value for which we've calculated the distance from the end of the path to the beginning, and then the heuristic is the distance between the node that we're considering and the final. So the summation of those two is going to give us the distance from the start to the end, or at least our best guess at it. And we can watch as we continue through this pathing until we end up with our final path from start to finish. Okay, so now when I move through, in a deterministic world, I'll always move along the path until we come to the end. So again, let's start over. I can run through my path making, and then I can run through my movement. Not much to see there, but it does go from start to finish. Let's try a different starting point. Alright, and then we'll put the end point here. Alright, so let's set that, and walk through our pathing process again. We'll do this rather quickly, so as not to waste too much time. Okay, so now A-star pathfinding has found our optimal path to get from start to finish. We'll step through the movement, and again, we find our way to the end. Alright, so now we're going to switch over to the stochastic model. So stochastic model shares the start and end. However, it'll only reset when the end point is changed, because the Q-learning learns a map for all nodes moving to the same endpoint. So we'll get back to that in a second. But just to show you the pathing, the step is one episode. So one episode of the Q-learning is going to be represented by the step, and most often we only see one update. But we'll be adding to the heat map. The heat map is a visual representation of what the Q values are for each node. So if you take a look at this node right here, so this is column 1, row 2, we can see that there is no possible action to move into this wall, and there's no possible action to move into this wall. But this triangle right here, this more opaque triangle, means that this the action to move from this node to this node has a greater Q value. So it would behoove the actor more when in this node to move to the left than it would to the top. And that's just based on what we've learned so far. So we're going to keep walking through these episodes until we reach our max episodes, which I have set at 100 right now, not visible to the GUI. But let me go ahead and run all the way through. So after 100 episodes, this is our learned model of the map. And if we try to move through here, we're going to move with stochasticism, move towards the best Q value with 60%, and then stay in the same place for 10%, and then the last 30% will be a random action. So we'll keep moving, and I'll try to move towards the target on the average. Get caught up a little bit. Until we get it to the final node. Okay, so I'm going to change my start state. Let's make him 0, 9. And we're going to step through that one more time. So we've got the same pathing, the same learned map, because we've only changed our start state, not our end state. The map is still valid. So I'm going to continue to step through. And the same thing, he's going to move towards the target with a 60% chance, and random action with 10%, excuse me, 30%, and then stay in his spot for 10. Okay, so we have shown that for a given endpoint, we can basically traverse to that endpoint for 2 different start points. So just for funsies, let's set the endpoint. Okay, so now that we've got a new point, our map has been reinitialized because we need to relearn the map for this endpoint. I'm going to step through the episodes. Again, we're going to slowly learn where to go for more and more nodes. And again, I'm just going to run it to the end. And that's our final model that we're going to get for our Q learning. And then just step through. Until we get to the end. Okay, and that concludes my submission to the Robotics Path Planning and Reinforcement Learning assignment. Thank you.